So I'm picking 4 modems of the working modems. So if I come down here, there are 20 total modems. There are 3 that are broken. So that means there's 17 that are working. So what makes me happy is that I pick all 4 that are working. So I'm picking 4 from the working. Just like on the other one, I picked 1 of the diodes. I'm picking 4 from the working.
Okay.
So I picked 4 from the working 17. And my total is 4 from the entire batch.
Okay.
Now, let me, just to give you another example on that one, what if I said there's 20 total, there were 3 that were defective, there were 17 working. What if I wanted to pick 4, like I was doing before, and I want to pick 1 broken and 3 working? So 20 total, 3 defective, 17 working, and I still am going to pick 4, but I'm picking 1 broken and 3 working. What is the probability of that happening? You're asking yourself, I'm picking brokens from the brokens, I'm picking working from the workings, and I'm picking total from the total. So how many brokens am I picking? 1. And how many brokens am I choosing from?
3.
How many workings am I picking?
3.
How many workings am I choosing from?
17.
How many total am I picking?
24.
From the 20 total. Does that help?
Yeah, I was looking at this one on the homework.
Uh-huh.
Does it change the problem whenever it says, like, what did the last part of, like that one said, if all 4 were, you accept the shipment, otherwise the shipment is rejected. So this one says if 1 or more is defective, the shipment is rejected. Does that change how you,
If
if one or more is defective?
If 1 or more.
Because I tried doing it the way that, like this way, but it was wrong.
If 1 or more is defective. So you're going to want to do, if 1 or more is defective, so I would do probably none. Hold on, I'll pull that one up in just a second. Because that sounds like it's a complement problem.
Yeah, and so I was confused because I thought it would be done the same way as like how so I was.
Yeah, let me pull that one up in just a second. What number is it?
Number 12.
Okay. Let me pull it up in just a second. All right, let's look at, I had 2 problems from 5.3 that we needed to look at. This one talks about, for a parallel structure, and so that you'll have it in your notes as well. I have, it's 5.3, number 5. it says for a parallel structure of identical components, the system can succeed. If at least one of the components succeeds, it will fail if, fail independently of each other, and that each component has a 0.15% or 15% probability of failure. So would it be unusual to observe one component fail? So it's a 0.15 of failure. So is it going to be unusual to fail? No, because this is greater than 0.05. So it would not be unusual because 0.15 is greater than the 0.05. Then it says for two components to fail. So how do we do two components? We square it, 0.15 times 0.15. So the way that we got this is we did 0.15 squared, or 0.15 times 0.15, that gave us that answer. And we said that would be unusual because that answer is smaller than 0.05. We good? Now, what is the probability that a parallel structures will succeed? Well, if two will fail, how do we get the succeed? 1 minus. So succeed equals 1 minus the fail. So if 2 succeeds, it's going to be 1 minus the 2 fails. So that's 0.15 squared. So if I come to my calculator and I do 1 minus the 0.15 squared, that's where that answer comes from. We good? Now, it's saying how many of these succeeds will make my answer greater than 0.19. So we just did 2 of those. I want to keep changing that until my answer gets bigger than 0.19. So I'm lazy. I'm going to do second enter and back that thing up and change it to a 3. Oops. Crap, I didn't back that thing up too well. There we go. To the 3rd. Is that greater than 0.999? Back it up to the 4th. Back it up to the 5th. I want it to be greater than 0.9999 with 4 nines. So it's going to be to the 5th power because they want it greater than, that's where that 5th is coming from.
Okay.
We good?
Yep.
All right, and then we had one more. This is 5.3, number 8. There's a 34% chance that when he goes to bat, he's going to successfully hit it. This says he goes to bat and makes an out. So if he hits it 34% of the time, what percent does he make an out? 34% hits it, 66% makes an out. And he does this 10 times, an out. So what is that going to be? What's your out? 0.66. And how many times are we doing it?
To the 10.
10 times. 0.66 to the 10th. The probability of a cold streak, is that answer more or less than 0.05? Less than, so it is unusual. Now, it's saying, when is my answer going to be that he strikes out all the time? They want to know when is it going to equal 0. So, I'm going to do the same thing that I did for the last one. I'm going to do 0.66. We know that to the 10th is small, but it's not small enough. So if I go to the 11th, I'm really not at 0 yet. So I'm going to skip up a couple. I'm going to go, oops, not that big. I'm going to go to the 13th. I'm still not at 0 because that rounds up. So then I'm gonna go, let's say to the 15th. That still rounds up to a 2. So then I'm gonna go to the 16th. And because that stays 1 or rounds down, that's why they're saying that it's the 16th power. So it's just like what we were doing, they want for it to round down and not round up.
Okay.
Yeah. All right, like I was saying, 5.6 is nothing more than reviewing. We said that disjoint events or independent events have nothing to do with, they have nothing in common. You can't be dead and alive. You can't fail and pass. So disjoint events are the same thing as independent, independent. They have nothing to do with each other. The multiple, and we've gone over these, I'm just kind of reviewing all of them at the same time. Multiplication, they're independent events, but they do not affect each other. You can get a good grade on your stats test, and it's raining. They have nothing to do with each other. And then we have conditional. Those are the ones where I said, in my classroom, how many are wearing glasses given that they're a boy? So I'm not looking at all 25 people, I'm looking at the 4 boys. So I want to know who's wearing glasses of the 4 boys. So my bottom number, my sample space would not be 25, it would be 4. That was my conditional probability. Flunking a test because you didn't study. So we're just going to go through and we're going to work some problems and I'm going to mix them up, which is really how it's going to be on your test. So even though I did not tell you that you had problems on your test from 5.6, you really do have your problems on your test from 5.6 because it's everything mixed up. This one talks about you are conducting a survey of 200 landlords, which means all of this together is 200. They've asked how long they stayed in their apartment, and the results are below. So now we can look at our question, construct a probability model for duration of vacancy. How do you do a probability model? Just like we did a relative frequency. 42 divided by 200, which they told us up there. 38 divided by 200, remember? And what should all of those add up to be? 1. So this would be 42 divided by 200, 38 divided by 200, and those can either be fractions, decimals, or percentages, and then they have to add up to 200. And then by the process of elimination, I have it all right here by the power of TV. We good? All right, second question. Is it unusual for an apartment to remain vacant for 2 years or more? Is it unusual for an apartment to remain vacant for 2 years or more?
Yes,
Why yes?
because it's less than 5%.
2 years or more is less than 0.05. So we would be using that answer, 0.04 is less than 0.05, so yes, it would be unusual. Y'all are learning more than you think. Determine the probability that a randomly selected apartment is vacant for 1 to 4 months. Let me see if I put my little table down here or not. Nope. Let me see if I can snag. Come on. 1 to 4 months. Copy. Paste. What is the probability that a randomly selected apartment is vacant for 1 to 4 months? What would you do? Tell me what to do.
Add 2 to 4, or 1 to 2 and 2 to 4.
So what would I be adding?
0.19 and
Point 19 plus,
0.225.
okay? Or I could go all the way back up to this one, and I would be adding 38 plus 45 over 200. They're gonna give me the same answer, y'all with me? There's my answer. 0.415. All right, determine the probability that a randomly selected apartment is vacant for less than 2 years. What's the easiest way to do that one?
That's 0.04.
1 minus over 2 years. Because you're not gonna want to add up all these other ones. You're gonna wanna do 1 minus 2 or more years. So it's gonna be 1 minus what? 0.04. So it's gonna be 0.96. Here's the pretty version. So far, so good? All right. Peyton's team consists of 10 girls, but only 5 can be on the field at any given time. 4 fielders and a goalie. How many starting lineups are possible if all players are started without regard to position played? Okay, so there's 10 girls standing there, all of them want to play. How many different ways can I pick from the 10 girls to put them on the field? How many ways can I pick 5 girls and say get on the field? Is this a permutation or is this a combination?
Combination.
Who?
Combination.
Combination. How many girls am I picking from? And how many am I choosing?
5.
That's it. Because it says I'm not paying attention to what fielder or goalie or whatever. I'm just saying 5 girls get on the field. We good? Some of y'all saw that answer before I could get it covered up.
Sorry, what does that question say for what team?
Just for that team.
What is
I think he's asking the sport.
I have no clue what that sport is. Do you want to Google it? FUTSAL? I have no idea. I have never heard of this sport. It sounds kind of like a soccer kind of sport. Has anybody heard of it?
I think someone misspelled football.
You
Or
think it's the football?
I think someone misspelled the
The game?
Latin
football?
American spelling of football.
Futsal? Futsal?
Is B close to S? I can't remember.
D? No. It's on the bottom middle and S is on the FUTSAL. Let's see if it's like a real thing. GOOGAL. Hold on. It won't even let me type.
How did you just spell Google?
The wrong way. I was trying to spell football in my head. All right, y'all, it won't even let me type. There's a conspiracy. Somebody Google and see if FUTSAL is a real thing. All right, FUTSAL.
No, it is actually a real thing.
Is it?
Yeah. It's like
It's like
soccer.
It's
like soccer.
It's like
but
indoor
you play on a
soccer.
hard court.
Indoor soccer.
It's played on a hard court smaller than a football field and mainly indoors.
Huh. Word of the day, futsal. My daughter learned how to play, she tried out for the middle school soccer team this year. Well, she's a cheerleader, like all cheerleader. And, she plays cheerleading for the, you don't play cheerleading, whatever you do cheerleading. And, like, cheerleading is all summer, all football season, all basketball season. And we literally have 2 months off. And she came to me and said, Mama, they called me into the office and they want me to try out for soccer. And I'm like, you don't run. Like, she just cheer, I mean, she can run, but she doesn't like to run. I'm like, you know nothing about soccer. You played every sport in the world except for soccer. You played tennis, you've done swimming, you've done golf, you've done everything, volleyball, softball. We know nothing about soccer. She's like, Mama, they called me to the office and asked me to play soccer. I said, evidently they don't know you. I keep it real with my child. And she's like, Mama, I promise, they told me to come try out. And I said, you know nothing. And come to find out, they didn't have enough people try out. And she had her updated physical, and they were hunting people with an up-to-date physical. And so she went and made the team, because they didn't have enough people try out. And she actually loved it. And it lasted the 2 months of our off time. And cheerleading tryouts for next year happened during the middle of soccer season. So the last half of soccer season, we were doing soccer and cheer. And now we're in the summer. She leaves. We go on our cruise next week. And then the day we get back from our cruise, she goes to College of Charleston for a week of cheer camp. And it all starts over. So yeah, I'll have to tell her about futsal. Yeah. Yes. So, how many starting lineups are possible if either Peyton or Jordan must play goalie? Now, at the top, it says 4 fielders and a goalie. 4 fielders, 1 goalie. How many starting lineups are possible if we have 4? So we're going to choose 4 fielders, 1 goalie. We're not doing 4 fielders, 1 goalie over total. Are we doing probability? 4 fielders, 1 goalie. No, we're just doing combinations. It didn't say probability. So, combination of fielders, combination. It didn't say probability, so we're not doing total. We're just doing total combinations. We're doing the sample space. This is my fielders. This is my goalie. And there were 10 players. So, Travis. Fielders. What's going here?
4.
4 goes here.
Yeah.
4 goes here. What's going to go here?
10.
So close. Let's start over here. What goes here? How many goalies are we choosing?
1.
And how many goalies do we have to choose from?
2.
2. Woohoo! We are picking 1 goalie, and we have 2 goalies to choose from.
But that says we only have 1 goalie. Oh, is the other 2 goalies in the A part of the question? Jordan
It's
and
gotta be
Peyton
one
are
of those
both
2 people.
goalies? Okay,
They're both possible goalies.
okay.
So, when you go, there's like usually on a team, there's like 1 or 2 goalies, and that's all they do is goalie. So, Peyton and Jordan, they're the only people that can stand in that goal. So, Peyton and Jordan are our goalie go-tos. So, one of them has to be the goalie.
Yeah.
So, we're picking 1 goalie from those 2 girls. You with me?
Yes.
Peyton or Jordan is going to go there. Now, for our fielders, how many fielders are we choosing? We're choosing 4 fielders. Give it to me, Travis.
Out of 8.
Oh!
9.
9. Even if we put Peyton as a goalie, Jordan can still go out there and field. So we got 9 players left. Because goalies can still play on the field, but fielders cannot play on the goalie. Because you got to be like really good. Yay? Is this better than the diet and regular Pepsi? Alright, let's get another one going.
I think I like the Pepsi's better.
Yeah. You like the Pepsi's better?
Yeah.
Ooh, some marijuana.
I like this.
We might like this one better. Alright, according to some statistical abstract, about 17% of all 18 to 25-year-old, how many of y'all are 18 to 25? Raise your hand, 18 and 25. Okay, over half the class. 17% of y'all are current marijuana users. What is the probability that 4 randomly selected 18 to 25-year-olds are all marijuana users? Now, right now, your mind is permutations, combinations. Is this a permutation combination problem?
No.
No. What kind of problem is this?
Wouldn't be, no.
Probability of a, I don't know, the E and Fs.
Anybody want to tell me how to do it? Come on, Barrett.
It's 0.17 to the 4th.
Air high five with a hug. There you go. He did it with the right hand too. If you do it with the other hand, then it's like you're hugging awkwardly. So he did it with the correct hand, so that we're hugging the correct way. Okay, so the probability that the first person is a user is 0.17. And we are picking 4 people. So the probability that the next person is a user, the probability, not that a user should be a smiley face, but the probability that the next person is a user. So the probability that we have 4 users is going to be 0.17 to the 4th power. 0.17 to the 4th power. Or whatever that is decimal-wise.
Well, it usually does put a smile on your face when you
It
use
does, that is what I have heard. It does, that's what I've heard. Now, for the next one. What is the probability that at least one,
Well, I didn't get that when I put that in my.
0.17 to the 4th power?
Yeah, I got like 8.3521 to the negative 4. I
Wow.
guess that would be right,
Wow.
because then I move them back.
0.8 who?
3521,
Times 10 to the,
negative 4.
No, it's 8.35.
oh, my bad.
Oh, yeah, thank you.
8 point, so the negative 4 means we're gonna do 1, 2, 3, 4.
Okay.
And 0, 0, 0, and they rounded it to the 1, 2, 3, 4, 5th power,
Okay,
so gave you 0, 0, 0, 8, 4.
got it. Okay, but would either answer be acceptable?
In my math lab, they're gonna say round it to 4 decimal, or 5 decimal places.
Okay.
So you're gonna have to whoop, 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 whoop,
Yep.
and then after you whoop, 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 then count back and round.
Okay.
Yep. So when I say at least one,
1 minus 1 minus.
we're gonna do 1 minus the 0.17 to the 4th. So it's gonna be 1 minus, ooh, no. What is this? At least one user is gonna be 1 minus no user to the 4th. What's the no users?
100 minus, or 1 minus 0.17.
The users were 0.17. So the no users are gonna be 1 minus 0.17, which is 0.83. That's your no user. So it's gonna be 0.83 to the fourth, 1 minus that. Because usually it's always, oh, take the one above it. This one kinda did not do that. So if I come down here, it's all written